Now you will get everywhere.
Yes, it didn't come properly.
Oh.
Okay, fine.
This one. Put this in your pocket. Down. Put here.
Hello. This is fine. Okay. Yeah. Okay, let's start. Okay. Right now we are trying to achieve speech recognition. It is considered to be an aspect of an intelligent being. So, I mean, it's a bit a daunting task even if you try to achieve that. And people are been working on it since past 30 years. And actually, the speech recognition has done 30 years back, but still, right? It was somehow not into the devices. And recently, we have started seeing it in mobile phones and on the internet also. Okay, let's begin with. Before going into the main talk, I wanted to put up this picture. I'm not sure whether it is clear. Can you see a blue dot here and there? Have you happened to see this image before? Everyone? Well, it's a image taken from Voyager 2 when it was about to cross Pluto's orbit. And it was on the request of former astrophysics. I forgot his name. So he requested purposefully. This image didn't have much significance, but he wanted. Can you switch off the slide, please? I can't see it. Okay, so he wants to give the perspective that all the human pursuit has been present on that blue dot. Yeah, that's fine. And given the vastness of the entire universe, our pursuit look insignificant. So, we now at this stage are trying to make our machine intelligent, and that's a big journey. Right from where we started as a group trying to survive in a social environment, trying to make stone tools, and from there, we are here now. So this is a group of two astronauts trying to work on something. But thing is, like somewhere between the trajectory, the development trajectory, starting from this point to this point, right? Somewhere lies our pursuit of making. Somewhere originated the thought of making the machine intelligent. So where was it exactly? So it was somewhere in the mid of 18th century. The clock makers or the watchmakers, they deviated from their profession and started making these mechanical dolls. And these dolls tried to imitate some of the human tasks like writing and playing music. So this was the first thing where we tried to imitate a person. And I have some videos here. So these are the two dolls. Well, the boy at the bottom, he is capable of writing as a human does, and he does it very precisely. And it was made in mid-17. And above was a doll, as it can play the music and many melodies, and she can be programmed to play many melodies. Thing is that if I wanted to bring out some key points, but for that, I think I skipped that slide, but still I have another one. Well, this is another mechanical doll, and it was the first machine which was programmable. it was meant for writing, and it was programmable in the sense you can see this circle, right? You can plug in the numbers, and actually you can make this machine to write any statement, any words. So this was the first programmable device, and the first successful attempt in getting something as a programmable, but not yet intelligent. So yeah, there were many of these dolls, and it was, I think, almost 250 years back, and that time technology was not much advanced. So people during those time, right, when they saw this doll in action, and saw these dolls actually imitating humans, and it was they were put into this thought like, is it possible for a human to come up with some intelligent machine? Is it possible to imitate some of the intelligent features? What is life like? Can it be imitated? All those philosophical questions came into them, and out of those came some novel and some thoughts. Like, this is the renowned characteristic Frankenstein. This was in the same era, 1880s. But some people went ahead to more formal work and came up with this. Anyone seen this before? Another one. It came from one gentleman, not Cisco Confidential. You can just guess what it was. This was in 1750s. Okay, now let's not waste time. It came from Charles Babbage, the father of modern computer science. But unfortunately, at his time, he was not able to complete his work because, given the technology at that time, he was not able to implement it completely. So it was just a paper work. But when the researchers of our time analyzed his work, they found it like this. His scheme was actually passing the Turing test, the Turing completeness, even before Alan Turing was born. So that was a bit fascinating, but it didn't took work, unfortunately, for the technology was not developed at this time. And when they decided to preserve his brain, because this was the first brain where all the modern computer notions has evolved. So it's nice to see some first mammalian brain preserved. But unfortunately, as I said, his work was lost, and it was rediscovered, as everyone knows now, by Alan Turing and von Neumann. And somewhere down the line in 1955, the term artificial intelligence was coined, and that was the first conference actually. Okay, so this was again the same question. This was the same questions, similar to that one which people faced when they actually saw that mechanical dolls in action. But this time it was a bit more formal way. They wanted to start it really well. People believed that they have technology, and they tried to answer this question in very formal ways. They try to answer what are the actual aspects of an intelligent life. And it's not required to know, but these are I've taken from a textbook, so it's much in depth, not really required to know. So we will try to see, as we are doing a speech recognition, and speech recognition requires you to train some models, and training is a learning aspect. So how you train a machine, how you ask a machine to learn something using the statistics. So I just highlighted this in the slides. So speech recognition task. Okay, so how we'll do it? We'll use statistic and try to mimic the learning aspect of intelligent form. So yeah, that's it. Okay, and we do it with this famous Bayes rule. So in schools, I never understood why A is there first and why B is first here, and I just blindly use this rule in solving problems until recently, right? When I saw there's a deep meaning behind it, and actually this is a framework of learning. How? Okay, before that, right, I just want to take a detour and pose this question: what is a model? Okay, there's a black box. And the black box has a screen, and on the screen you will be seeing this number at a series of number 1, 2, 3, right up to 5 and 12, and then the sequence repeats. So the question is, what is in this box? Yeah, easy one. So what you exactly did now is just you model this box. You just tried to we actually gave a rational reason for the behavior of this box. Okay, this was very defined, like very confined to the power x. But some system, right, unfortunately can't be done that way. So we need to have probabilistic model. But what is it exactly? Consider this game of shooting or the bullseye. So if I pose a question now, can you guess out of these three, which one is a beginner, which one is an intermediate, and which one is an advanced? And it's very trivial. You can just make out from the visual that this guy must be an advanced user, because in the mind what you see, right, you just try to map unconsciously these plots, and which comes out to be the famous Gaussian distribution. Well, this is a probabilistic modeling. Now, ironically, this is a function. If you increase the value of x, we get a function which is similar to this deterministic, but the form here is probabilistic because we are not actually varying x from 0 to infinity. We were just trying to find out the values of this mu and sigma, which is this mean and variation. Of course, everyone must know. So this is probabilistic modeling. Well, let's back to the question that what is the framework of learning and how we are going to use this probabilistic modeling for a learning thing. And yet, I think I missed one slide. Thing is that we use the Bayes law. Again, this, as it said, right, very casually, that our brains are Bayesian engines. The thing is that right from our birth, we try to develop the perception of people, perception of world around us, and then we come up with these small models or small interpretations. Like, for example, if this brain happens to be a brain of a terrorist, then he will think this guy is some good guy for himself. He wants to kill John Jumper because he's an American, and even Michael Jackson maybe. That's what is in his mind. So that's how he's trained. His mind is trained for. That's how his mind has the model of a real world in his mind. That's how he has learned how things are. But well, this is a much formal one where the things get a bit messy when we have these equations. Okay, I just put this graph intentionally. Okay, so consider this graph of time versus belief. So time is a person. Suppose the person is born at time 0 and he has a wrong belief of the world, like he believes in fairy tales. But as he learns, right, he sees the world is cruel, right? And slowly he will develop his belief towards somewhat where his maturity level will come and stabilize to this point where this is the point where he sees that he knows the whole world very perfectly and he gets rude and arrogant and doesn't try to learn further, so he stops here. So this thing, right, this graph can be captured using this equation. Okay, now what is A and B? So A is a belief, like how he sees the world. B is the events that happens, like mistakes he does, or the things like which will cause to change his belief. So he starts from his birth A0, and then he will update his belief like A, given some event B has happened in his life. So he corrects his perception about the world. What we do now, he is updated, and we just plug this value here, and as the event keeps on happening in his life, we keep on updating this belief. And this is how happens in on speech recognition. We train our model till the point where they reach some value where we say that now this model is properly trained according to the given one. We'll see that later. Similarly, just like people, we store word models also in our head. Okay, consider this example when two humans are talking. He says like time flies like an arrow, and the other guy replies it a normal human way. But suppose you're trying to say it to a machine now. It has got added noise here, and this machine in our time now, it is able to recognize it. Fortunately, we in this time where it does it very robustly. But the further question is like how it will interpret it. This was I have taken from one of the lecture notes of it's a course of AI. This is very interesting. He tries to interpret like there are some time flies which actually are fond of arrows. So he got complete wrong impression of it. So this is another problem which lies behind above speech recognition. But we'll just see. I just wanted to put this in front of you, telling that it's a bit complex when you have a machine in front of you and you have a task of making them intelligent. Okay, we do speech recognition. This is the entire slide just depicts the problem completely. Now what we do is we record the signals and then we chop it into a 20 millisecond time frame. We do a feature extraction, and this feature extraction can be seen as in some observation, like first 20 millisecond, then next, and so on up till the signal lasts. And what we do next is we just feed this observation to some model we have already trained, and then we use a Viterbi algorithm on that model and just try to find the probability given this observation sequence, which of the model in your vocabulary would have caused it. So that's the problem. The same thing. The question is we need to find this. Wi are the model. Like suppose you have 10 words, then you will have 10 models, and like one I from 1 to 10. And now we will use the Bayes rule again to split this thing into this problem. And this is somehow difficult to calculate. I don't know why. I never understood it. And then they say in the literature that this is, since it's hard to compute, we use HMM. Now this is HMM is hidden Markov model. And I never understood it initially, but now I think I have a better understanding of it. Model, what is model? We just discussed. What is Markov model? It is like saying that my behavior today is dependent on yesterday, not on the past. It is just saying that my present behavior is just dependent on immediate past in very informal language, and not on the entire history from the day I'm born. And what is hidden? Markov model. Hidden is like when I showed you the sequence of 1, 2, and 2 raised to power x, you immediately came up with some rational explanation. So that was something hidden which you predicted. That was something which you inferred, say, while after observing the sequence. Well, that wasn't hidden. There was something hidden which you just inferred. So it is very informal definition which I have here, or which my professor would have killed me being so informal. Okay, this is an example, very lucid example which I picked from Wikipedia about HMM. Suppose there is a clinic in a village, and these people in this village have a very nice property. Nice property that whenever you go and confront them and ask about their health, they will usually reply that they either are normal today, or they feel dizzy or cold. That's a very good property they have, and nothing else. I mean, they say, I don't know, or something with cold that is. No, they will just reply with normal, dizzy and cold. And there's a doctor in this clinic, and he is a bit disturbed with this behavior of the villagers. So he tries to come up with some rational reason why these people are behaving in this way. So he works on, and because of his experience over the time, he comes up with this. Now this is called, can be said as a hidden model. It's a hidden Markov model. Now initially the doctor didn't have any idea why the villagers are behaving in a particular way. And then he comes up with this explanation. Now he has a complete understanding of the people. So then a villager, he goes and asks a villager, and he observes him for a period of 3 days. On the first day he meets him and asks, on first day villager says that he feels normal. The next day he says, I'm feeling cold. And the third he says dizzy. Now it's up to the doctor to decide what is happening with him. Is he healthy, or does he has some fever? So what he does is, he just go home and just write down all the possible things which could have been caused this behavior. So all this state, right? All this state, fever, and there are 8 states possible out of it, and all of them can produce the same behavior, like normal, cold, and dizzy. But using if you use the Viterbi algorithm on this thing, you will find out that this state, this is the most likely sequence with the highest probability, which would have caused this behavior. So we do similarly some similar thing on our models. We have some observations, feature extraction. So based on this observation, just like the doctor observes the patient, based on this observation, and given these models, like based on this observation and given this model, we try to compute probabilities. And what we do, probability of all the models. These are the word models. Like I said, if there are 10 words, there will be 10 models. So we will have 10 values. And what we will do is, we'll pick up the maximum one. So the explanation to this, maybe this is the most, this is the word model, and most likely this word would have caused this observation sequence to appear. So that's how we say, that's how the machine says, yes, I have detected this word, but it doesn't say, it says in terms of probability, because this was the most likely thing it find out. Okay? I have a demo which I have recorded. Before. Well, I tried to come up with some set of command to control that GUI, which was which you. Oh, where's the presentation? I tried to come up with a set of command which can use to mimic or imitate this mic, and this had some names, user name. It had Brewer also when he was here, and some of the commands to control pan and tilt, and that was the video. What I was not able to implement all the commands because I'll just come later. So how we do is, right, there's a word select, and we can break this word into these phonemes. What's this? And yeah, this was my dictionary which I generated. What I did was I took all this word and found out what is this phoneme it was, and there are some well-defined dictionaries, but I need to create some my own because to match it to an Indian accent. So I just need I need to edit some of this phonemes myself, and I had just made some phonemes in colored one. So this A appears at some of the places. So what the idea is, in English language there are some 27 to 30, I don't know what number, but some limited set of phonemes. And what you need to do is you generate a model, or HMM model for all those phonemes. And why to do that? Because to have a model for each English word, there are like 1,000, 50,000, more than that English words. So that is a big daunting task. So what you do is just have a model for the 30 models for all this phoneme. And then you just combine. You have A, like this is the word, suppose back. So you have B, A, and you just join them together. So you take any word, break into the phoneme, and pick up the respective phoneme model and just club them together this way. So I have separately trained this model, this phonemes, and then just clubbing it to get the actual word HMM model. It's a rather acoustic model. I'm not trying to use these terms. Okay, so I just try to give the comparative thing which we try to achieve and what Google are doing. So the time spent was 8 months doing part-time, and Google took it 8 years. So if you visit their site and see, they have research paper from 2007. Sorry, and then just for this. And yeah, you got the point. So actually this, I have written this thing in achieved goal, but it's not that robust. So I just got some recipe I cooked up and it's not very tasty. So it's something like that. So it's not very robust. But these guys have done excellent job. I mean, they have made. If you want to see the demo of this thing, just open your Google Chrome in your Android phone and use the speech recognition API. I don't need to give any further demo. You can see it for yourself. So these guys are went ahead. Thing which I want to point out here is that I'm not that I'm smarter than them, but this thing of achieving the complexity of achieving all these things is much higher. It requires a lot of effort to do this, and fortunately, these guys are making it available to public through the research work. So that's big generous from their side. Yeah, the thing is these things are much complex and it can't be achieved doing it part-time. Something like this model can be achieved. Okay, this is an analogy which I'm just continuing. Now, you say of face detection, that's now possible and very robust. But if you say of speech recognition, it is much tougher problem than face detection. And in formal way, you can say that speech recognition has much more constraint than face detection. So this problem is very simple. I mean, it's nothing in front of this. So these things to achieve this in a robust way, there are many constraints you need to satisfy. So let's see and consider this I just want to say how things get complicated when you add constraint. So this is a two-dimensional plane, and this blue area, I'm asking you to select any point on that plane, and it's very easy. There are infinite points which you can select. Now I put a constraint on you that I just want all the points which lie on this side of the line, and that is represented by blue area. I add another constraint, and now the area has reduced. I keep on adding constraint. I keep on trying to make that problem more difficult, trying to make it more robust. I'm trying to achieve face recognition. Now I have face detection. I keep on adding this constraint. And now this area is reducing. What I'm trying to say is the complexity increases too much when you try to get robust and much more robust features. And this blue area, you are reducing this is proportional to time and complexity. That's what I wanted to say. And I want to leave you with this comment which I picked up from the Google site. Now these guys, as I said, they have come up with Chrome, and they are making their work available to general public. So soon we will be seeing low-end or low-cost video solutions which are much smarter. Now, in all the stocks there are being in our view, we are trying to get smart features. Well, that is good, but the feature like speech recognition, face recognition, if our devices are actually able to do that, we will be actually putting our devices into new category of intelligent devices. Altogether new categories, intelligent devices. So that is a big step actually. And it's very eminent that in near future, very low-end solutions and very intelligent one that too will be available because of these guys. And if you really want to have this thing, then we should start soon, because 8 years they took an 8 years, and they are seeing the result now. And it will be. It's not that we want. If you decide now, okay, we can do this feature at a later point of time, but as the time goes on and as this intelligent device come up, we will be forced to do this in any way. Like that will be pressure to come up with such devices. So this line, I think you just keep in mind this. This is which I want you to think on. And this is just a site where they have openly put up all their research so far in the last 8 years. Thank you. Oops.
Have you tried any other probabilistic model to train your data, like CRF or something else?
No, I haven't tried because it took a long. Yeah, the question was, is there some other modeling technique other than HMM? And yes, it is. Certainly there it is, and this Google guys have come up. It's again a probabilistic model. They are using neural nets. In fact, deep neural nets, and I haven't tried that because like it took myself like working part time to reach here, so I didn't got any extra time to do that. Yeah. Yeah.
What was the Markov order then you used?
It was the question is what was the Markov order which I used, and it's the first order. If I would have increased the order, things would have got much complicated.
Have you measured the accuracy as a official? As a very formal accurate model? Like how much accurate is this application?
Yeah, the question is like how accurate is this prototype which I had developed. I haven't done a formal assessment of it, but I just tried quantitative something. Like I have tried 70 words, and out of 70 words, 70 times the same word, and out of 70 times it had recognized, I think 70% of times, 75% of time. So it's not very robust. Still, I got the recipe how to do it. I just cooked it, and yeah, that's the dish now. So next thing is to try it again and make it more robust.
I had done something similar as part of my college last year project, project. So we had used Julius Oxford's open source speech engine for the same. So the accuracy with that was about 94 to 97%. They have done all the estimates. So it's the suggestion.
I haven't heard of that. But even this HTK which I have using, it is guaranteed, not guaranteed because it's probabilistic, everything are probabilistic. But still, right, as I said, I just got the recipe, I cooked up. So thing is that I need to tweak it, and actually I can get, with the present scenario, I'm supposed to get 99% accuracy with the isolated word recognition.
Training data was isolated
Yeah.
words or
The question is how was the training data generated?
how many words or something you tried to train?
So the question is how big was the training data and how was it obtained? There is a training data being put up by universities, but I can't use them because it's not according to Indian accent. So I need to record some 300 sentences for each word. So like I did the recording myself, and there were some 300 sentences, and then it was a tedious task. Like you need to record and then you need to break down. Actually, you need to have a recording speech file and a text file which says that this recording belongs to this word and this recording is split into this phoneme. So it is a very tedious task. So I myself did all the recording and creating a dictionary, just transcribing it into phonemes. So it is a very tedious task. Fortunately, now there is Google that helps, I believe, so we can use some of their work to do cloud computing. And as another slide, like the cloud computing was come up in another presentation, so looks like that's a trend, and we should use that. Yeah. One more question. Done? Yeah. Thank you.
Before we go to the next presentation, I would like to remind